Hi guys, a very good evening to all of you. So in our today's lecture, we are going to start off with the new concept known as set theory. Okay, set theory. Let's begin. Okay, so in this chapter, we're going to learn about what is set, what is grouping, how to construct different sets together, how to differentiate two or three things, and how to differentiate and how to write what are Venn diagrams, what are set, what is uniform, union, intersection, belongs to, like, different signs are there. Okay, so we'll be starting off with everything and anything of this chapter, but first let me see whether everything is working well and good. Okay, one second. Okay, as I can see, everything is working properly. Let's continue with the class. So first is, what are sets? Okay, see, a very fine example of sets are, let's take, like, let me bring some pens and everything. Okay, so see, here in this particular cup, as you can see, there is a cup, right? So there are a few scales, there are a few pencils, color pencils, and two pens. Okay, so here this entire cup actually, like, let us see whatever there is, like how many things are present inside the cup. Okay, so inside the cup there are three scales. Okay, there are two pens, and there are one, two, three, four, five, six, seven pencils. Okay, so see, the totally in the cup, if I say what are present. Okay, so totally inside the cup, what are present? I can say there are three scales, two pens, and seven pencils. Okay, so totally there are how many things? Let us write it down. Let us understand everything. Like, let's not memorize everything, and let's understand what it is. Okay, so see, I'm already carrying a cup. Okay, so in this cup, what are the things that are present? Pencils are present. Number of pencils is 7. Pens are present. Number of pens are 2. And lastly, scale or ruler, that are 3. So total number of objects that are present inside the cup are 7, 8, 9, 10, 11, 12. 12 objects are present, in which the first group is what, of pencils. So group 1 is pencil, group 2 is pens, and group 3 is ruler. Okay, so let us write this down. Okay, how will we write this? So set of objects in cups. Okay, set of objects in cups, set of pens inside cup, set of pencils inside cup. So the answer will be different for different things. This is what is the basic of sets. Okay, sets is nothing but grouping uh, a whole lot of data into parts that we can distinguish each other from. Okay, so if you have any problem understanding this, we'll be watching videos, we'll be understanding everything one by one. See, where do we see sets? See, this is a set of animals inside the animal kingdom. Can you see this? Here, these are human beings. Okay, so we are different kind of human beings, right? Different race, different, like, people are present in different parts of the world. Some are Caucasian, some are dark skinned, some are brown skin like us, and some have different facial structures, different hair structures, and everything. So entirety belongs to the human sets. Okay, so we are human, male, female, everything. After that, we have all the animals present. Okay, see, different kind of animals, even bats, bears, bull, pig, pigeon, whale. These are all different kinds of animal present. So this entire universal set, there is a term known as universal set. Universal set means whatever is present to the entirety of the set. That universal set in this particular diagram is actually the animal kingdom. Okay, inside animal kingdom, we are of one particular set, subset, we are a part of the animal kingdom, right? The subset is humans, and we are even a part of that universal set, that is the animal kingdom. Okay, see, first set we have been written is a set of what? Shapes. First is first, second, third, fourth, fifth. So there are five shapes. So these are set of shapes. Okay. Second is a set of numbers. Third is a set of animals. Fourth is a set of flowers. Did you get it? One second. I think there is some issue. No. Okay. Let's continue. Now, basic concept. Okay. Let me go there so you can see the screen properly. A set is a well-defined collection of distinct objects. We have already made that pretty sure. Considered as an object in its own right. Okay. These objects are called the elements or members of a set. Okay. So in this particular example that we just did, each and every one, like each one pen, each one pencil, each one ruler is all an object or elements of a set. Okay. Next. See, if I write this, like see, whatever first we'll understand what the question is telling us, what this is telling us. Elements of a set. A is actually a set which contains 1, 2, 3, 4. Okay. Is a set containing the numbers 1, 2, 3, and 4, where 1, 2, 3, 4 are the elements or members of a set. Okay. So this is very self-explanatory, but if you still want me to, one second, guys. So if I write another set B and I say this is pen, pencil, ruler. So in this particular set B, we have three elements: pen, pencil, and ruler. Okay. So this is how sets are different. So we can write numbers, we can write objects, things, anything and everything. Okay. Just we have to make sure that we are keeping this inside a particular. See, this second bracket is very important. Okay. Second bracket is actually what defines a set. We have to write this set inside a second bracket. Next. Okay. Now, what is this symbol known as? This symbol is known as belongs to. Okay. This symbol E, okay, belongs to, and this notifies does not belongs to, does not belong to. Okay, see, and slash is there, that is cutting. So E or whatever that is E, so I can say that this is E or epsilon, but we read this as E is actually belongs to and E slash does not belongs to. So see, for example, this set P. In set P we have 3, 6, 8, 13, 18. So if I write 3 belongs to P, yes, 3 is present inside P. 13 belongs to P, yes. 18 belongs to P, yes. 6 belongs to P, yes. If I write a number like 17 or 23, is it a part of this set? No. So 17 is does not belongs to P. 23 does not belongs to P. Okay. Did you understand, guys? Let's continue. Now, elements in a set can be written as, see, we have already done this, right? So second bracket, A, B, C, D, second bracket, 1, 2, 3, 4, second bracket, pencil, pen, eraser, sharpener, whatever we want to write. Okay. But set, see, one word can be written only once. See, there is one thing. So if I write set of letters of word cattle, set of letters of word cattle. So I'll write set A is equal to C A T T L E. See, in this particular thing, you can see one thing, double T is present, but that is not allowed. Okay, we can write one object only once, so this is not allowed. So actually this will become C A T L E. Okay. Similarly, see the example is written here crook. See R double OK, but we are not going to write that O twice. We're going to write that O once. Okay. Next. Now, representation of set. A set is generally represented in description method form, set builder or rule method, tabular or roster method form. Okay, we'll be understanding everything. Okay, you can write it in any one of the methods, it's up to you. First is examples of all type of representation. Okay, see, n is a set of natural numbers, so this we are directly writing what this is. Okay, n is a set of natural numbers, so it starts with 1 and goes to positive infinity. Set of natural numbers. Okay, this is a descriptive method. We are describing what the set is all about. Okay, second is see. Second one is roster tabular method, where we are signifying what are the terms that are present inside. Okay, so 1 2 3 4 5 6 7 until positive infinity. Okay, third one is the set builder rule method. Okay, this is according to me the most difficult to write sometimes, but see, we have to learn something new, right, in everything. So there are a few things that we have to learn. This sign is x such that x, this is read as x such that x is a rational number, or x such that x belongs to natural number. So n stands for natural number, w stands for whole number, z or I stands for integer. Okay, these are a few basic like terminologies that we have to understand. Okay, see, this is known as such that. This colon sign is known as such that in set. So we have understood the three types, okay, that we should write. So set of natural numbers, first one descriptive method, second one tabular method, and third one is the set builder or rule method. Okay, give it a watch guys first for 1 second. Okay, chalo. Next. Now we have to do some question on our own. Okay, pause the video and try to do it. I'll still give you 10 seconds time to do it. Try to do it, guys. Okay. Now see, what is this? What is the question? In a school, there are 40 students in total. Okay. 25 students are enrolled in the science stream, 20 students are enrolled in the commerce stream, and 10 students are enrolled in both streams. Okay. So let us understand S represents certain number of students in science streams. Okay. C represents the set of students in commerce stream, represent the sets in one description form, two roster form, and three set builder form. Okay, so first is we have to represent S. See, S is actually what? Science stream. C is commerce stream. Okay, one represent the sets in description form. Okay, so the first one is S is students studying in science stream. Okay. Similarly, description for the second one, students studying in commerce stream. Done. Roster form is where we have to understand. See, roster form is that S is equal to bracket. We will write the names or the numbers of the 25 students. Okay. So here we cannot write 25 as a whole. We can have to write 1, 2, 3, 4 like that. We have to specify all the 25 students that are present. Okay. Similarly for the commerce students. Okay, and lastly set builder form, where we have to understand that set builder form S belongs to X is to X belongs to students in science. Okay, see, this particular sum we have to understand using Venn diagram. Okay, then I'll make you understand using Venn diagram as well, because this is not the correct representation of this sum. Okay, firstly, let's see. First is in a school, in a student, the total students, let me write down, is 40. So I'm drawing a circle. I'm drawing one more circle. Okay, two circles. This first circle is for science. Second circle is for commerce. Okay, we have seen in the question only 10 students are enrolled in both. So 10 students are enrolled in both. So remaining students, we have 25 students in science stream in which 10 are already enrolled. So we are left with 15. Similarly, 20 students are there. So 10 are enrolled in commerce but are not taking science. So total, we are coming out to be 35 students. See, but total actually is 40. So 5 students are there who is not taken either science or commerce. Okay. So this sum shouldn't be given right away, but this actually is a sum of Venn diagram where we understand what are these. Let me explain it to you again. So 10 student does both. Okay. 10 student does both. So 10 plus 15, 25. So 25 students are enrolled in science. 10 plus 10, 20. 20 are enrolled in commerce. And 5 students are not even enrolled in science, not in commerce. Okay. Next. See, description from same thing. Then comes, see, we have to name all the students I've told you, no, in roster from student 1, student 2, student 3, everyone. Then set builder. See, most, like for me, this is the most gruesome of all those three, where we have to describe everything. Okay. So X, this is actually, this will be not a slash sign. This will be X such that X, not X dash X. This won't be the case. Okay. Next, cardinal numbers. Okay, so cardinal numbers is very easy. Don't have to read anything. Okay, if I write a set and I name the set Z, Z is equal to, and I'm writing 2, 4, 6, 8, 10. So cardinal number of Z will be write by how? We'll be writing Z with dash dash. Then we'll count the number of elements. So 1, 2, 3, 4, 5. So this is 5. That's it. That's actually it for cardinal number. Set A contains a 1, 2, 3. How many elements are present in set A? 3. Cardinal number of A is 3. That's it. Okay. It is very easy to understand. At least cardinal number is. Next, types of set. See, finite, infinite, empty, null set, disjoint set, joint set, equal set, equivalence, and singleton sets. Everything will be done. Okay. See, finite set, as the name suggests, are finite in nature. For example, if I tell you, write all the natural numbers between 1 or no, let's give it a question like this. Find all the natural numbers less than 10. Okay, so we know that is 1, 2, 3, 4, 5, 6, 7, 8, 9. See, it is getting completed. So finite, we can actually write everything down. Even if you say that all the natural numbers below 10 million, still we can count that. That is also counted as a finite set. Infinite set, what is that? Number of planets in the universe, something like that. Okay, number of uh, air molecules, number of times from the start of the creation of the earth, the sun rose from the east and sets in the west, something like that. That cannot be counted by any means possible. Okay, these are known as infinite sets. Okay, next is empty or null sets. For example, if I say negative numbers between 1 and 5, no negative numbers between plus 1 and plus 5, right? That is a null set. If I say something like this, these are number set. If I say, what is this possibility that the sun rises from the west? You're like, what are you even saying, sir? Sun cannot rise from the earth. Again, this is a null or void set. Cannot be possible. Okay. So empty or null set join. Disjoint sets are when two sets are not related to each other. Let me give you an example. So if I write a set A, 1, 2, 3, 4, 5. Set B, 6, 7, 8, 9, 10. No elements are in common. No elements are in common among these two. So these two are disjoint sets. Easy. Joint sets, if I say 10, then 1, 2, 3, 4, 5. Okay. And now after writing everything, okay, see, B actually contains all the elements of A. So A is a subset of B. A is a subset of B. Okay. After that, joint sets are also when both of them are connected by some sort. So these two are joint sets because both of them are connected because A has 1, 2, 3, 4, 5. B has 1 from 1 to 10. So B also has 1, 2, 3, 4, 5. So these two are joint sets. Okay. Now equal sets. Equal sets is again very easy to understand. If I write 1, 2, 3, 4, 5. So these two are actually equal. Okay. That is what is called equal sets. Then comes equivalent set. Equivalent sets is true when we find for cardinal numbers. So if I write here 6, 7, 8, 9, 10. Okay, cardinal number of A is 5. Cardinal number of B is 5. So these two are okay equal sets, and equivalent sets means see these two are equal sets. Okay, but equivalent sets will have only be happening when both of them have equal elements and same and equal element, like same to same. These are known as equivalent sets. Okay, singlets will be using with an example. Single sets or singleton sets is very easy. When a set A is 1, that is it, single cell, one, just one element on a cell, that is known as single sets or singlet cell or singletons. Okay, now let's again finish this up. I've already explained it to you. Okay, so finite set is a set that contains a specific number of elements In other words, the elements of the sets can be counted and set has a definite limited number of elements. Already explained this to you. Next, infinite set, something that cannot be counted. If I write what are the natural numbers present, it can start from 1, what can end can positive infinity. Similarly, if I write what is the like smallest integer possible, okay, so negative infinity, again infinite set. Next, empty or null set, where there cannot be anything. I've already told you that if I write positive number between -5 and -7, there is no positive number between -5 and -7. So this is what do you call a null set or empty set. Okay. Now disjoint set, where no elements are in common. That's it. Disjoint set. 5, 7, 9, 4, 6, 2, 5. Disjoint, we do not have any elements in common. Next, joint sets. Joint sets which have like overlapping, so as they have some elements in common, they are known as joint sets. Equal sets, okay, when they are absolutely the same, that is what is equal sets. Equivalent set, when the number of elements are same. Okay, I think I reversed the two, but now you know, right? Equal sets are when absolutely both of them are set like same. Equivalent set when the number of elements are same. Okay. Now we'll be doing some examples. In a shopping mall, there are two types of shop. 15 clothing shop, 10 electronic stores, and 5 sells both clothing and electronics. Okay. C represents the set of clothing stores. E represents the set of electronic stores. How many clothing stores do not sell electronics? How many electronics stores sell either clothing or electronics? Are the set C and E disjoint? Okay. I'll be utilizing a Venn diagram. Okay, to solve this, let's begin. First circle, second circle. Okay, first circle signifies clothing stores. So clothing. Second circle signifies electronics. Electronics. See, firstly, whenever we have something in common, the five store sells both clothing and electronics. So in the middle, it will come the five sets. Okay, so five in the middle. Okay. Now 15 clothing stores are there. The total clothing stores are 15. So we already have 5 here. So remaining what? 10, because 10 plus 5 gives us 50. Similarly, 10 electronic stores, 5 is already there. So 5 more. Okay. So we have found out the what is this. Now let us find out how many clothing stores do not sell electronics. Okay. How many clothing stores do not sell electronics? So 10 clothing stores do not sell electronic, because 5 of them sell both of them, right? So 10 does not store anything. How many stores sell either clothing or electronics? See, when either comes into being, we are not going to take those 5 stores that are selling both. So either they can sell this or that. So 10 plus 5, 15. 10 comes from here, 5 comes from here. Okay, either selling clothing or electronics. Okay, are the sets C and E disjoint? So they are not disjoint because they have this 5 stores in common. I hope you understood. Okay, see, this Venn diagram is the best way possible to do these sums. Okay, best way possible. No formula, no nothing. We have to memorize nothing. We just have to understand. But still, if you want to know what are the formulas are, this is known as intersection. Intersection. This is known as union. Okay, these two are the signs that are present inside sets. This is union, this is intersection, these are all formulas. So I'm not someone who's going to mug, like you have to memorize formulas anyways. Okay, so if you understand the thing with the basics, you can be solving it without like needing help with any formulas. Okay, now subset. Okay, one second. Now come the concept of subset. I've already made you understand. See, in this are all the fruits that are present in the world. So I'm taking up some fruits that are yellow in color, like banana, pineapple, lemon. Similarly, I have taken some fruits that are red in color, watermelon, strawberry. I think this is a cherry, apple. What is this? No idea, but some fruit. Okay. So all red colors, red color fruit is a set. Yellow color fruit is another set. They both are disjoint to each other, but they all of them are subsets of the total universal set of fruits. Okay, each of them are fruits, right? This is what is known as subset. Let us go to the definition. A subset is a set where every element of that set is also an element of another set. In other words, if you have two sets, say A and B, A is a subset of B if every element in A is also in B. Okay, so this is the sign. Okay, A is a subset, every element of B. So the bigger one that contains everything should be written first. This this is the subset form, like subset sign. This one, this U, the dash. Okay. Now let's take this example. A is 1, 2, 3 and B is 1, 2, 3, 4, 5. So B has everything already that A has. So we can say that B, okay, A is a subset of B because A, 1, 2, 3 are in B. Simple. A is a subset of B in every element. Okay. So they are saying that the one that is a subset, this A, this is the smaller one. This is the smaller one and this is the bigger one. Oh, it is the same. Like like this only, no? So when we used to do greater than lesser than, the one that has the open mouth is bigger. That is exactly what this is. Okay, I hope you understood the concept of subsets. Now superset. See, superset is the opposite of subset. A set B is called a superset of A if every element of A is also an element of B. Okay. In notation, if A, U dash, okay, B, we said that B is a superset of A, written as B ulta then A. So I don't know what to call this sign, but I write super, like you will practice and you will be calling it like that. A is a subset of B, B is a superset of A. Okay. So see, this is something that is very important. If A is a subset of B, B already becomes a superset of A. This and this are same. Okay. Next, proper subset. Okay. A proper subset is a set in which all the elements of the set are contained in another set, but the two sets are not identical. In other words, a set A is a proper subset of set B, denoted as A is a part of B if every element of A is also an element of B. Let A is equal to 1, 2, 3 and B is 1, 2, 3, 4. A is a proper subset of B because all the elements of A are in B. But A is not equal to B since B has an extra element, that is 4. Okay. Thus, A is a proper subset of B is true, but A is a subset of B is true, but A is a proper subset of B is not true. Okay. So only if I add here, if I add 1, 4 here, then okay, then it becomes an equivalent set. Okay. Thus A is a proper subset of B, which is A is a proper subset of B is true and A is a proper subset. Oh, it's the same thing written. Okay, I thought something else. Next, number of subsets and number of proper subsets of a given subset. Okay, see, this is where we have to memorize. Like I'll tell you, there are some things that we have to memorize. So this is that part. Okay, so number of subsets 2 raised to the power n. Now, what is that n? Number of terms. Okay, number of elements. Number of what do you say? A, B, 2, so 2, N. Okay, number of elements, we are already understood what are elements. Number of subsets, okay, 2 to the power 2. Number of proper sets, it's 1 less. Okay, so if I give you an example, A is 1, 5, 7. Okay, so number of subsets of A is going to be 2 to the power 3. This is subsets. And proper subset will be is 2 to the power 3 minus 1. So 8, this is 7. Okay. So where did this 3 come from? Number of elements. The 1 plus 1 plus 1 is equal to 3. Okay. Next. Now universal set. This is something that we have been doing. The Venn diagram wala thing. The entire, like this entire like whatever is present inside that rectangle is actually the universal set. Universal sets contains everything there is to do in a particular sum. Okay, so U contains everything, 1, 2, 3, 4, 5, 6, 7, everything. Okay, whatever is present here, everything. A contains 3, 4 and 5. B contains 1 and 5. Okay. Now operations on set. We have been always doing, we already did some few operations, but we'll be learning everything. Now, let's utilize this example only. Okay. So as we can see in A, from this diagram, I'm using this diagram. A, we have what? We have 1, 0, 3, 5, 8. Okay. So I'm writing in ascending order. So 0, 1, 3, 5, 8. And B contains what? B contains again 8, 5, but 2 and 9 as well. So 2, 5, 8, 9. Okay. Now these two are the elements of the set A and B that we have found out. Okay. Now union means what? A union B is we are going to write everything that is there, A and B. So let's start off with 0, 1, 2, 2, 3, 4 is not there, 5, 8, 9. But we are not going to be writing 5 and 8 twice, okay? Only once. If this is union, then intersection B will be the ones that are common. So common are what? 8 and 5. We are writing 8 and 5 as intersection. Okay. So U is union, ulta U is intersection. Okay. I don't know what is written here. So this is different, this is different. Sure. Now this is intersection already done with this. Now operations. See, A minus B, B minus A. Whatever, like when we subtract, it's the same thing. A minus B, we're subtracting whatever the common element of B is there from A. Okay. So let's utilize this example only. So set A has 5, 6, 7, 8, 9. So set A, let me draw it here. Set A has 5. Let's first see what are the common one. 6 and 8 are common. So 6 and 8 are common. So 6 and 8 goes here. 5 and 7 goes here. 5, 7, 9 goes here. 4 and 10 goes here. This is set A. This is set B. Okay. This is the Venn diagram. Now A minus B. So A has this all, but we are not allowed to take this. We are not allowed to take these two because they are also a part of B. So A minus B is going to be just 9, 5 and 7. Okay. So if I write B minus A, it will be again we are not allowed this and this. We are remaining with 4 and 10. So the answer here is 4 comma 10. That's it. It is that easy. Okay. Next. So at a birthday party, there are two sets of people. Set A, children who like chocolate ice cream. Set B, children who like strawberry ice cream. Okay. There are 10 children in set A and 8 children in set B. And 4 children in C. Let us use Venn diagram again because Venn diagram is the easiest. First, second. Let me change the ink to black. See, set there are 10 children in set A. The total in set A 10 children are there. Set A, this is B. But first, when there is how do I understand the set is going to be intersecting? Like one एक के ऊपर एक होगा. Because it's written 4 children who like both. Both term जब रहेगा, तब that 4 will come in the middle. Okay. Now total 10, we have already utilized 4, so 6 is present in case of A. And B, 4 are already here, so rest is 4 because total is 8. That is it. Now, what we have to find out, how many children like either chocolate or strawberry ice cream. So, either chocolate or strawberry ice cream, 6 plus 4, that is 10. Okay. Second, also, how many children like both chocolate and strawberry ice cream? That is already given. How many children like both strawberry and ice cream? So this is 4 already given in the question only. Okay. This, like if you are making a Venn diagram, it is that easy to understand. Okay. See, same. Why use formulas and everything? Because it is that easy to understand. But still, if you want to write formula, this is the formula. A union B cardinal number is equal to A cardinal plus B cardinal minus A intersection B cardinal. Okay. It's up to you whether you want to do it or not. Simply like use Venn diagrams to solve this because it is allowed and plus it is very easy to understand. Okay. Now cardinal properties of sets. 1 second. Okay. Last thing that is there. If a set has 10 elements in it, we say its cardinal number is 10 and write is at NAS equal to 10. See, if I write set A is equal to 1, 2, 5, 7, 9, 77, 61. Okay. So firstly, if I write cardinal number of A We will count the number of elements. So 1, 2, 3, 4, 5, 6, 7. Current number of A is 7. But if you want to write in this format, so we have to write what? N number of cardinal A is equal to 7. So these and these are absolutely same. Okay. I hope you understood. So in the second example, if said B 2, 4, 6, 8, 12, number of elements 6. So N B is this, or we can write this same. Okay. Okay. So that is the end of the class for the day. I hope you understood something about set theory. It's very easy concept. Do not go buy the book and everything that you will have to understand this within one instant only. Okay, watch this video once or twice. Try to solve some sums and use Venn diagrams to solve sums probably. Okay, that should be really easy for you to understand. Okay, have a great evening. Bye bye.